OK，很高兴今天大家来到这个我们今天早上这个Arduino 这个 project 的这个一个 session 哈。那我们 Arduino 其实它事实上是一个就是说蛮好玩的一个 project。好，就是说在过去我们在这个 open source 的社群里面，其实我们 create 很多 software。好，但是呢，事实上呢，说我们很少有机会接触到一些 open hardware 的东西。那 COSCUP 在过去几年中，其实我们有做一些尝试，想要把一些 open hardware 的题目放到这个整个这种 community 里面来。好，但是实际上这些 project 基本上大部分都没有很成功。但是Arduino 事实上是在过去这几年来，我们看到一个非常成功的一个open hardware 的发掘。好，那在我们过去 open source 的这个领域里，我们 create 很多这种不同的这种 software 的 project 出来。好，那但是呢，这个 software 毕竟只是我们所以拿到那个装置的一部分。好，那 Arduino 这个 project 事实上提供了我们一个机会，好，使得我们可以create 一个就是说一个我们自己的 gadget 出来。好，那我们今天很高兴请到了就 Arduino 这个 project 的 founder David Cuartielles，is that correct？ OK，David Cuartielles 来为我们分享他们在这个Arduino 这个 project 过去几年中他们在不管各式各样不同的领域里面所造成一个结果。然后尤其他们今天的题目主要是在讲说如何使用这 Arduino 这个东西当做课堂上的一个工具。好，那这个东西的话，事实上呢，就是说可以让就是说在一个学生甚至小孩子从小开始接触这样的一个 open hardware 这样的一个电子方面的东西这个事实上是就说使得这些学生或者是小孩子，他可以从做中学，然后得到一些非常宝贵的经验。So let's welcome the David Cuartielles for the talk of the Arduino in the DIY classroom.
Hello. Get sound on this one. Hola, hola. It's not on. Oh, great. I'm the hardware guy. So I'm going to make this talk a bit slow because I got told that I get no direct translation. So as you see, I really don't speak any Chinese at all. And my English is pretty bad as well because I'm from Spain. But I will try to at least make it funny. So I'm here representing a lot of people. I am a researcher at Malmö University College in Sweden. And I am a co-founder of the platform Arduino, which is like this. Arduino is an open hardware platform, but before I talk to you about Arduino, I need to explain to you about the context when it was created. It was created by 5 people. This is the so-called Arduino team. I'm representing myself and all the other 4 men in there. I have to say, Arduino, for those that don't know, is right now a small company, it's a small startup that has been running for 6 years. And in there you can see all my partners, Gianluca, Dave, there is myself, Tom, and Massimo. If you have any questions about anybody in the team, I will be glad to answer later on. So the context when Arduino shows up as an open hardware platform, it doesn't show up from, let's say, an engineering lab. It shows up when we try to bring the world of digital electronics to designers and artists. We had this kind of complicated task that was to try to bring the way we design, when I mean designing home appliances, to the world of electronics, to the world of connected objects. So we had these different disciplines that needed to get access to use electronics as part of their creative process. And since I am assuming that in this room right now, the majority of you are so-called coders or programmers or software engineers or somehow in the craft of making things with software, I have to briefly introduce you to some of the basic aspects of what interaction design is, the field that inspired the Arduino board. So, in the first place, interaction design is about establishing meaningful relationships between humans and artifacts. And I can explain this easily with this slide here. Well, this is how my OpenOffice renders SVG files. So, but that is an on-off icon. And you will agree with me that the on-off icon, the circle with the stick, does not mean anything in any culture. Or it does mean now, but it didn't mean 15, 20 years ago. And we have, in this case, designers look for a way of looking for some sort of icon that could be identified as an action that we perform with machines every day. On the other hand, interaction design is dealing with the creation of beautiful interactions between humans and artifacts. And you will agree with me that there is aesthetical values on the machines. There's a reason why people choose a certain type of machine versus a different type of machine. And again, taking analogies in the icons world, if we look for an RSS icon for our website, there's like a lot of choices we can take. And we will choose one versus the other ones for some particular reason. We like it more if it's better with our CSS or whatever. Finally, there is a relationship of tension between humans and machines. And I like to talk about it in this way. You remember, well, you probably, we're in Asia. I'm sure you have a completely different relationship to phones as we do in Spain, but 15 years ago, a person having a mobile phone at a cafe, sitting on a table, was being very unpolite to his friends because it meant they was always connected to work. But nowadays, if you don't have a mobile phone with you, you are very antisocial because you can't connect to Facebook. So as you see, there is a tension in the way we relate to the machines. And that's, again, something that had to be explored by designers. So the question for us in 2005 is, how could we bring the craft of electronics and digital technology to the craft of design so that designers could actually try to understand the implications of technology? This was our task. And that's why we created Arduino. And this board you see on the picture right now is one that is being manufactured over 350,000 times. I will say it again, 350,000. And it's an open source project. So I'm here today to explain you the story of this open source project. So Arduino is in essence four things. Is that circuit board you saw? That circuit board is a small computer that runs at 16 megahertz and has 32 kilobytes of memory, which means it's more powerful than my first Commodore 64. There has a difference with the Commodore 64 though. It has no keyboard, it has no screen, it has no direct way of interaction with the user. It's in essence a piece of embedded electronics. So in order to program this computer, we need an external software development environment. That is the second point in my slide. And then again, as I explained, we created this system not for engineers to produce new electronic devices, but for designers to learn about the craft of electronics. So we needed to create an educational method for people that probably didn't have a knowledge in software, they didn't have a knowledge in math or eventually in physics. And so we had to teach about electronics from the top down. Like, this is how you turn something on and off. Doesn't matter that you don't understand how electricity flows, but you can still do it. And finally, just making fun of Steve Ballmer, we don't do developers. We look at community, and community. So the Arduino ecology is in essence something like this. It's boards. I will use the laser pointer. It's boards, it's software, it's an education method that we summarize on a website, and it's our community. The thing is that we started with one board that had 14 inputs and outputs, but has generated such an interest and attraction that we had to start creating more and more boards and devices for people to be able of developing new things. You might be interested in making a bit of a more complex thing, so we made a board with 54 inputs and outputs. Or you might be interested in designing something over Bluetooth, or over the XB protocol, or over Ethernet, or eventually make a wearable computer, and you want to stitch your electronics to fabrics. So depending on the scenario of use, you might need a different piece of hardware. the important thing is that all these different pieces of hardware, they behave in the exact same way. It doesn't matter if it's stitched to your jacket or if it's inside a model. Like if you activate one pin, that pin will be activated the same way in the different systems. This is the software. This is the software environment, and this is a very simple example that turns on or configures one pin as an output, turns it on, waits a little bit, turns it off, and waits a little bit. I mean, you can imagine that with a language like this one, it's very simple to do a lot of things, to the point that, as I will show later, we created this for designers, and it's now being used by secondary school students to design robots. Just to prove the point that this thing works fine, I'm going to make a quick demo. And they say they should never make live demos on conferences, but you know what? I'm going to show that this works. And I will have more problems with the solid projector than with the actual demo. 1 second. So this is the Arduino Uno board. It's the current design that we have out there. And you see this board the board has a bunch of inputs and outputs. And there has a small LED light in there. And you can't really see it, but this LED is actually connected to the pin number 13, 1-3. So if I activate pin number 13 in my software, it's going to be directly addressing that pin. I'm going to take a piece of software here. This is the IDE, and it's made in Java for those that are interested. The Arduino system works in C. So this IDE is basically calling a C compiler that compiles everything and then sends everything up to the board. Which means that you could eventually rewrite the software in whatever other system you like. Some Venezuelan activists rewrote the IDE to work in Python because they hate Java so much. So it's perfectly possible to rewrite the thing in whatever language you like. So this program here, again, configures pin 13 as an output. Then it turns the pin on. It has a pin on for 200 milliseconds. I'm going to change this to be a bit of a bigger number, like 1 second. Turns the pin off. And, oops, what did I do? Sorry, I don't really see. And then it will turn the pin on for another second. I upload this program to the board. Oh, I made a mistake. Oh, yeah. I can't really see anything, so you have to excuse me now. That is good. So now this guy is compiling, sends everything here. These two LEDs flash really quick, and the program was changed. You see now, that program is flashing at once per second. Well, in the same way, I could turn this lamp on and off. I could turn 20 lamps on and off. I could control anything over the SPI port or I2C or whatever. I could control a motor or anything. So there is a million examples right now out there of people doing things with Arduino boards. So right now, as I said, we have a website that it's a compilation of all the documentation that you can find about Arduino, more or less. It's what we call the official reference, and it's written in English. And it's been actively translated by people to different languages in an open wiki that we maintain. But the strongest part of our whole system is our forum that right now has over 50,000 registered users, of which I would say 30 or 40% are very, very active. And they support people in questions from, oh, I bought an Arduino board, how can I plug this thing to my computer, to how can I launch a rocket? You know, it's like a very broad range of questions. This graph here represents the access to our website over the years. We have statistics since 2005, 2006, all the way to 2011. This graph is only going until March 2011, and you can see that we have an exponential growth in visits to the website up to about 45 million visits month, or hits month, sorry. And this I mean, I cannot give you data on the actual sales of Arduino boards because the Arduino project does not sell boards. We only make reference designs. Somebody else manufactures and sells. But I can tell you that this curve translates very much into the curve of sales from the manufacturers. So the growth of the project is exponential as for today. And the question to me is more how this growth is represented among the different countries in the world. And I spent some time with a doctor in economy analyzing the data from our servers, trying to figure out what was relevant and what is not relevant. Based on a survey that we made a survey among our users, and we saw this, that a lot of our user base is concentrated in the United States. And then I wondered, is it actually true? Because as you know, the States is well known for having a very strong maker culture. By maker, I mean people that try to build things by themselves. What happens with the rest of the world? So we started to analyze the data coming from our servers. We came to this graph that represents the composition by continent of people that are coming to the Arduino servers. And you can see that the green area represents North America, the yellow area represents Europe, and the orange area represents Asia. The other continents, I mean, are poorly represented due to different reasons. And the thing is, like, it's very interesting to see, you see the explosion in both Asia and Europe at some point in 2009. The reason for this, funny enough, is because of American media. I don't know how it is in Asia, I know how it is in Europe. In Europe there is, since we are a conglomerate of many different countries, many different cultures with many different languages, it's not like a leading force in media that we are all looking into to, you know, get information about open hardware or software in general. But in the US, because they have a single language and have a single culture, they do have. What happens is that the European media looks at the US media. So when in 2008, Wired magazine published a cover story about the Arduino project, there was an explosion a couple of months later in the European media that provoked an explosion in the European user base in the Arduino project, which is very interesting. So in a way, what we learned here is that as an open source project, in order to get exposure in our own region, we had to sell really, really well in the United States, which is very funny, because it's the country that runs 70% of Windows machines. So what is that we were interested in when we made these graphs? We were interested in trying to understand how does the average Arduino user look like. You know, as a project, if you want to grow, you need to understand which is your user base, like your current user base, and which is your goal. As the Arduino project, and this is the point of my talk here, we are, of course, interested in the design students that we've been aiming as a target until now, but we are much more interested in high school students and secondary school students, because as an educational project, our goal is to change the way people learn about digital technology. And maybe the university is a little bit late to enter with this. You know, it's like we believe that we have to enter secondary schools, and digital technology commands our lives nowadays. So we had to try to understand which was our user base. And out of these graphs and out of the statistics and surveys we made, we realized that we have a very strong user base that is male between 20 and 40, with an interest in technology, that use Windows. We have 70% of Windows users, which means we cannot really disregard that. But they use Firefox. I mean, have to get some credit. They usually had no prior experience in digital electronics. There was a lot of software engineers being interested in trying out something physically in the real world. With an internet connection, I mean, of course, if we are looking at internet statistics, it's people with an internet connection. So we have like no idea about people with no internet connection, unfortunately. And that's Google a lot. So we ask our users a question about how do you access the Arduino content? How do you access the Arduino reference? And they say, oh, I go to Google and I type Arduino pin mode, and then get information about how to configure a pin in Arduino, while that information is local in their computers. the whole Arduino reference is downloaded to your computer when you download the software development system. But people don't know they have it, so they go to Google, and they think they cannot really work if they are not online. So as a joke, I made this website. It's the Arduino Google website, where you could type in the search box Arduino terms, and we'll look for them for you. This website is actually, it was working up until this morning, so it should be working now, but please don't tell Google that we made it, because they registered the idea of having a changing icon up here. So they might, bring me to court. But a very important thing with the Arduino project is what people do. As a project that is about making things, I mean, we make a prototyping platform, and we don't only concentrate in documenting how our platform works, but also we concentrate in trying to show what people are doing. And that's a very important thing to encourage other people to do things. This is a little bit different from other open source projects. If you look at OpenOffice, OpenOffice is not really promoting the books written by people in OpenOffice, right? But this is our role. We make a platform that is about building things. So we have to concentrate in telling people, look, this was built with Arduino. There are this many projects built with Arduino, so that we can inspire other people. So which are the challenges that we find to bring this to the educational world? And again, when I talk about education, I don't talk any longer about university education. I assume that Arduino is already at every other university in the world. I'm looking into secondary and high school education. First, that we provide the tools, but not the books. This is very important. There is a very strong, already established market for people producing books for education. As Arduino, our message is, don't buy books, buy boards. It's like all the information is on the internet, and it's for free, and it's free to download, and it's a million blogs that explain how to make a million projects. What you need is tools to get started. So we don't provide people with books, we provide people with tools. Then it's all about getting an introduction to the fun aspects of applied science. I mean, there is a lot of things that need to be learned. This is just a teaser to invite you to go into it. It doesn't mean that you have to get rid of learning math. It means that this can invite people to learn math. Then it's a peer-to-peer education method. We try to avoid the masterclass system. We work in projects, we let people share projects with others, and we evaluate things in group. It's like, in my class, for example, if I have 30 students, people work in couples, so I have 15 projects, and the projects are co-evaluated by the other students. We work under a critique basis. And it's about letting people own the platform, which means we let people critique the platform, and we take their critique very seriously and change it, and make the tools open source and make the contents open source. I don't know if I've said it until now, but all the hardware design in the Arduino platform is open source. You can download our circuit board design from the internet and manufacture your own boards. All the software is GPL. All the firmware is CPL, which means you can just take everything and replicate it. As long as you don't call it Arduino, you can make our project your project. So this has changed a lot, traditional concepts of how to understand the classroom. The first one is that the laboratory is not any longer that place for people with white coats. For me, a laboratory is like this. This is the cafeteria at my university. We don't have a proper laboratory space, so we just meet in the cafe and we just hack things together. I mean, this of course existed already before in hacker spaces, but we're trying to bring this into academia, that more informal places can invite people to do things and learn in different ways. On the other hand, we're also looking at how people communicate. I'm a trained microelectronics engineer, and I understand that it's not easy to read, for example, a circuit schematic. So I work with students, and they send me messages like this one. This is an LED strip, and this a 50 meters long LED strip, and it has cutting marks, as you see, in different parts. That tell you if you cut this here, and you plug 24 volts between these 2 points, this whole LED strip is going to shine beautifully in the same white color. what the students don't know is that you can cut it anywhere else and it will still shine in the same beautiful white color. Especially when they don't know in-depth electronics, they don't know if they can cut before or after this component here, you know. So I get these messages, this kind of messages, like this one I got it at 2 a.m. in the night from 2 students working in a project. And you will think, which kind of project were they doing? Well, they were doing this. This is an interactive rocking chair that shines as if it was filled up with water. And when the chair rocks back and forth, the lights go like. This was made by 2 design students in their second year at the bachelor class with no prior knowledge in electronics or software. So you can get a bit of a picture of what people can actually do with the right kind of message provided to them. Also, what we have working with is the idea of prototyping. You know, a prototype in a traditional engineering method is not really something you hack together. We do a lot of prototypes like this, and we try to bring this idea to education, like you can make things in a piece of cardboard, and it's just what you need to learn how things work. Of course, you just, with your imagination, fill this in and make it look like something else. And finally, the thing that our project is really bringing is a discussion about what is open hardware. You know, when we started in 2005, people started to ask us, what is open hardware? Because we said, our hardware is open, just take it. And truth is that we couldn't answer that question. I mean, as I showed you earlier, Arduino until now has been a 5-man operation, even though we are now growing, but it's really hard for 5 people to just say how you have to license something that is actually physical. And it hasn't been until last year that we finally managed to gather a lot of different companies together back in the US and discuss about what it meant to have something that was open and made in hardware. Because it's not just about electronics, it could be anything made in wood or plastics, or could be a bicycle or a helicopter or a car. Anything that is physical is hardware, of course. And the problem with hardware is that as soon as an accident happens with it, the manufacturer is liable for the accident. So if you want to follow our development in how to create a hardware license, you can just go to this website and check it out. So this was the first part of my talk. I spoke for, I think, like 35 minutes. So now I have a couple of examples and eventually a demo. If there is no time for making a demo, I think that tonight is going to be like an open time for coming and asking questions about Arduino, so you're welcome to come later. I will try to be there. So I want to show you a couple of examples made by different people around the world. So I guess that many of you are familiar with this circuit board up here. I will ask, do you know what this is? You can raise up your hand. Those that know, like 2 people. Okay, but you know Google, right? Do you guys know Google? That very small company from the States? Well, that very small company from the States that just bought Motorola, like, oh, let's go buy something with 19,000 workers. One day they woke up and said, oh, we want to make something to display the possibilities of building up your own physical accessories to the Android operating system, which means, let's imagine you want to have like a heartbeat monitor for your exercising machine that you can easily connect to your phone. How could you prototype that system? And they came up with the idea of using an Arduino board to prototype their prototyping platform. You know, Google, that very small company from the States, went to check out this very small company, like even smaller with 5 people, and said, oh, look, they have a very nice hardware design. We can take their basic design and make our own prototyping platform based on their platform. And you know, guys, this is open source, and they follow the open source rules, and so they did. So they did the Google ADK, which is this board that is used to prototype different systems. Since we are a very happy open source company, it took us a week to just make our own version of their version of our version. I can say that again. Our version of their version of our version, that is not on the slide. But as a small company, in the same way that Google did this without telling us anything, we are ready to collaborate with bigger companies. We actually collaborated with Telefónica from Spain in making these radio modems that are allowing people to prototype machine-to-machine systems. You know, the latest buzzword in the mobile business is machine-to-machine. The GSM/GPRS networks are, the patents for those networks has run out, so now it's very, very cheap to design devices that are going to run on the GSM wireless system. So all the telcos in the world are very, very interested in people creating the alarm clock that will connect every morning to the internet and download the weather, because they will make money on that interaction of your alarm clock with the infrastructure. So Telefónica from Spain has been very, very glad to support Arduino in designing this. They have put 3 engineers full-time, 6 months, to make this for us. Something that we can't really pay as an open source project with the kind of money we generate, but they can pay, they can pay for us. And the best part is that they are open sourcing the whole design under our license, which is good. And since Google did this, somebody had the idea that why shouldn't the iOS platform also have something to connect to the physical world? So they made this $59 cable to connect Arduino boards to the iPhone. So now you have like no excuse not to design interactive physical devices for your mobile platforms. You can do it both in Android and iPhone. And since I got told that WebOS is phasing out, then there is only 2 platforms to play with. As you see, I'm not even considering Windows Mobile. So this is another example made by Sebastian. Sebastian, with his Debian t-shirt, is 14 years old. And he lives in Chile, and he had the idea that it would be interesting to monitor earthquakes. So he designed an earthquake monitor using an Arduino Ethernet board that is twittering when there is an earthquake alert. I don't know how many thousand Twitter followers he's having right now for this project. As you see, I mean, I haven't really shown you an Arduino Ethernet board. I just showed you an Arduino Uno board. But the Arduino Ethernet connects to the internet doing something as simple as board.connect and then the URL. You know, it's that easy. So that allows someone like Sebastian to just make this project easily and put it online and get it to work. I don't know if you're familiar with the RevRap project. The RevRap project is a self-replicating 3D printer, and it happens to be running on Arduino Mega. Today in the conference, there will be a session about RevRap, and so I would like to invite you all to go check it out. There is an endless amount of robots. This is a robot made out of recycled pieces. You might recognize this from a deodorant. This is a robot made at a high school in Spain by a teacher that works with students that are having issues in their education. So they are kind of like thrown to him. And he teaches them electronics. And since they have a very limited budget, they build robots out of like scrap. Actually, the most expensive part is the Arduino board in the whole construction. This is yet another robot. And this robot, I designed this robot last year based on a constraint that is that even though we make open source hardware designs, there is a fact, and it's not possible to find the parts everywhere in the world. For example, the microcontroller that we use for our boards is a 32 kilobytes microcontroller. It's very, very easy to find in Europe or the US. In countries like Korea, you don't find that microcontroller. In countries like Mexico, you don't find that microcontroller. So even though it's open source, it doesn't mean that it's easy to manufacture. So the whole design has to be localized for the specific cases. So as part of a collaboration with the Spanish Agency of International Cooperation, I designed this robot for Mexican kids to be able of learning about electronics, where all the parts, absolutely every part of this robot can be found in the electronics market in the Mexico City. This is like the complete opposite. This is a very expensive competition robot that runs on an Arduino Mega. I don't know if you're familiar with RoboCup. RoboCup is the robotics competition, world robotics competition, where the kids learn how to make robots that play football. So about 40% of the robots that play football are made using Arduino boards. This is about a 3,000 euros expensive robot compared to this one that, compared to this one that costs like 50 euros or this one that costs like 30 euros. The thing is that these robots are made 100% by teenagers, and they are not allowed to get any help from adults. When they go to compete, they have to make a 1 hour long speech presenting their robot and how it works. And many of these robots, they actually work with distributed computing. They have one processor to control all the sensors on a small screen, and one processor to just drive the motors. As I said, Arduino was initially made for design and art projects, and there is a lot of art projects that are working with Arduino. When I show this picture, it's really hard to relate an Arduino board to it. This is an art piece made by an artist called Daniel Palacios, and it's a 5 meters long elastic string that can represent stationary waves and can produce shapes as beautiful as the one that you see here. And these shapes are generated by two motors that spin at different speeds. And the two motors are controlled by one single Arduino board that is measuring the movement around the podiums. Well, some other piece, you get some better pictures of that. This is a virtual reality helmet, as I like to call it, that is prototype on a bucket. This is a classic design scenario that I find with my students at the university. They have an idea, they want to pursue it, they have 2 weeks, and in 2 weeks they can put things together like this. This is a helmet that is called the X-Sense, and it gathers sounds from the environment and transforms them into images. This is the final product, you see, from this concept to this finalization. This is how the helmet looked like in an exhibition space. This is probably the first Arduino project ever made, and I want to show you this one because I consider it very interesting. It's called the involuntary dance machine. And the idea behind this project was to take control on the human body. And in this case, my students were very interested in looking at how a person would feel, a person with full control of his or her body would feel, or taking that control away from him or her. So I thought about a performance where a dancer would dance a certain dance, and they would add electrodes to the knees and elbows and provoke an electroshock that would force this person to move an arm or a knee, depending on the frequency of the sound. They realized that at some point, if you get electroshocks in both knees at the same time, you might fall, and that hurts. So they had to hang the person with a chain from the ceiling. And they made this performance that I'm going to show you now. You can find this on YouTube. The thing is that during this performance, people were having so much fun that it's almost impossible to hear the music. You can just see the guy dancing. Again, I mean, I don't recommend anybody doing this, but as I said, I have a degree in microelectronics and I studied medical electronics, so I was assisting the students in making this project. But with a 9-volt battery, you can do fantastic things on the human body. I will stop this. I mean, it's really a lot of fun to watch, but you can Google it yourself, and it's 3 minutes of pure laughter. The interesting thing with this project is that people were looking at the projection like this one, and they could anticipate which was the name that was going to get electroshocked. They could anticipate, oh, it's going to be his elbow. Look at the elbow. It was fantastic. As I said, we've been working a lot with generating contents for secondary schools, and this is really my goal, and this is really what I'm working with right now. In the last 3 years, I've been concentrating on making the Arduino website work. I was just showing you earlier the Arduino website statistics, and I have to say I feel really, really proud of reaching that value. And I've been more or less a system administrator for making sure that we could, you know, fulfill the traffic requirements of our audience. In parallel, I'm a researcher and I work at Malmö University as a teacher or professor. And I'm concentrating in creating contents for secondary schools. This is an example of a project made by my students where it's a combination of a piece of software that represents the bloodstream or the blood flow and a physical object that controls the blood flow. You can decide which white cells you are going to use to counterpart bacteria infection. So these bacteria are taking over your bloodstream, and you have to decide which are the white cells you're going to use. This is a game, obviously, but it's a game that is not played under the same constraints as a normal computer game. You don't get any points. Either you live or you die. You know, it's the only thing you can do. The longer you play, this means the longer you live. And the whole point is to learn about complex systems like the blood flow, where you have to choose some of your kamikaze white cells to set them to be infected and die, and that death of those white cells will inform your spine about which is the ones that you can actually create to fight the infection. If you try to fight the infection from the beginning, you will probably lose the game. You have to get the right data before. So this is the kind of game that you play just once or twice in your life, just to learn about complex systems. And well, this is actually my final slide. And I have to say there is a lot of science projects being made using Arduino boards. And some of the funniest ones are actually including like low distance rocket launching. In the US, sponsored by NASA, there's been a bunch of experiments where they are launching the so-called CAN satellites. There are small satellites in the size of a Coca-Cola can that include inside electronics to monitor the data of how the rocket is launched and how the satellite then falls with a parachute. Many of them are designed with Arduino boards. So this is, I have to say, I got told that this picture was from one of those experiments. That's why I put it here, but I'm not 100%. There is an Arduino in that rocket, but I wish it is, you know. If it is, I'm really proud, and if it's not, okay, what can I say? So this was all for me. Thank you very much.
所以那个有没有人有问题 ？Is there any question?
Is this open hardware because you want artificial interface and output electronic board, so you design it, right? Not based electronic because you want the artificial.
Oh, sorry, I didn't understand the question at all.
My meaning is why you design this product, because the art or because the electronics, because the art or the electronic.
I didn't understand.
你可以用中文
啊，就是说它这个东西，它这个 Arduino 这个产品，就是说是基于电子还是基于艺术去构想的。
So his question is that when you start the Arduino projects, are you come from the artist's point of view or it comes from the electronics point of view. So.
Yeah.
So how we shifted our point of view.
Yeah, your point of view. So when you start a Arduino project, so is there some requirement from the artist or from the practical reason, or you just want to make a board for others?
Okay.
Yeah.
Okay. Yeah, that's a really good question, actually. When we started, as I explained, we were really focused on industrial design students and interaction design students. And by extension, artists became very interested because there is many artists that want to use electronics in their physical production. So personally, I worked a lot with artists, helping them out to make projects. I say I worked in the past because right now I don't really have the time. But we didn't do a board just for making a board. We did a board because it had a purpose. You know, it's, our goal was to educate people and to help them make things.
So,
okay, thank you.
Yeah,
okay, thank you.
Okay.
Thank you. There is one there and one there. You can use the microphones on the tables. Just press talk.
我先用中文问一遍哦，会比较清楚啊。那我想请问，讲者就是说有关于 Arduino 啊，是不是适合把一个比较小的 OS kernel， 像譬如说是小型版本的 Linux 放到 Arduino 上面哦？那这样到底这样做不知道是算不算合理？那我再用英文问一遍哈。Is it reasonable for us to porting small size Linux on the Arduino board? What do you think about? Thank you.
I have really bad audio. I can't hear.
Yeah, he's asking. Currently, the Arduino does not have any operating system on it. So, operating system.
Okay.
Yeah. So, is it possible to port an operating system to the Arduino board?
Okay. I would say we don't show any examples with operating systems because at this point with the hardware we have released officially, it is very hard for our target audience to understand. But there is versions of RTOS and BirdOS and some others that work on the microcontrollers that we are using. So it's actually possible to run an operating system very trimmed down on our system. Also, I have to say that from September 17th, we will make an announcement of a new board, and I cannot say any more, so about something that can run operating systems. So I would say it is possible. Yeah, yeah. There's one question there.
Is there an interactive debugging environment like GDB to interactively to debug the program in interactive debugging environment?
No.
Yes. No.
Because, yeah, I mean, no, it's a really good question, obviously. I mean, many people are interested in simulators and interactive debugging and so on. The thing is, like, we try to make this as cheap as possible. So we had to leave away a lot of the engineering paradigms on how to design electronics. And one of them was a simulator, and the other one was the debugger. Because if we had to spend engineering hours creating that, it would cost too much money. The thing is that since we started until today, I mean, there have been a lot of people creating simulators of the ABR ATmega family, which is the processors we are using. So I think it's possible now to make it. We don't have it, but it's possible. I think time is over.
Okay. I think the time is over now. So let's thank for the David for today's presentation. So if you have any question, you can go to him. Okay. Thank you.
Thank you very much.
大会这边有一件事情报告哈，那个 在等一下茶点的时间呢，可以到询问处去领取 Linux 派来的杂志。那我不知道这个数量有多少，所以想要的人赶快过去吧。
Yeah.
This is Professor Lee from the
Oh, okay. I was visiting 4 years ago.
4 years ago.
Yeah, I made this. Oh, David, I'm sorry, I have no business cards.
No, that's all right.
You know Casey Reese from UCLA, who made processing. We made a tour, he and me. We toured all the different campuses from UC in like 6 days. So we made like lecture in Santa Barbara, San Diego, UCLA, Irvine, Santa Cruz, and Berkeley.
Okay.
In like 6 days, 3 days, 6 campuses. It was like a marathon.
Okay.
Yeah.
Yeah. We actually right now we are working on a project at Taiwan University.
Okay.
You know, even though my full time is in Irvine, actually I have a project at Taiwan University sponsored by Intel. And Yozong is part of the team.
Okay.
So we are actually trying to build some middleware on top of Arduino.
Okay.
And we're probably going to be choosing some more powerful ones because if you don't put the middleware, you cannot use this really tiny ones. Okay. So that is one thing that we eventually we try to cover a lot of even in the case Yozong's interested in design some new hardware to support it also.
Yeah, as the question was from the audience, if we can run operating systems, for example. We are bringing out the board with ARM.